All right, Kaylin works as a production engineer. She's working with a machine part that has a tolerance of 0.04 millimeters and a nominal value of 0.50 millimeters, which is halfway between the maximum and the minimum. Okay, state the maximum and minimum values of the machine part. Okay, here I want you to imagine this. I want you to imagine like the highest possible value, which is our max. I want you to think of the lowest, which is our min. And I talked about the fact that the difference between these two is your tolerance, right? Tolerance is 0.04. Maybe I will add that here in a bit. I will review that part. But the tolerance is the difference between, tolerance is max minus min. That is what tolerance is. That's how you could find it. And what are they telling us? The nominal is the target. Maybe I'll say that here as well. Nominal is the target measurement. Target measurement. That's what they're aiming for. The target could be, if you're paying attention to this part, the target could be anywhere here. It could be anywhere, but the question is telling me that it is exactly halfway. So I'm actually going to use a different color. This is my nominal. And that is, in this case, 0.50. Okay. So if it's exactly halfway, you're with me here? Then that means that this tolerance is spread equally here and here. Wouldn't you agree? Like this here is 0.02 and this is 0.02. Right? Because if the tolerance, like if the difference between the highest and the lowest is 0.04 and the nominal, our target, is right in between, we can actually split this. They don't do this very, they kind of are moving away from this part, but I still think it's important to understand. Okay. So can we figure out, so if this is 0.50, what would the minimum be? How would we get from here to here using this value? You would go this minus that would get you to the minimum. Okay, so it's a little messy here, but I'm just going to show you here. 0.50 minus 0.02, that's 0.48 millimeters. And then 0.5, which is the target, plus 0.02, that'd be 0.52 millimeters. And look, do the math. It is 4.04 millimeters between the two. If you subtract max and min, you would get 0.04 back. So how should I say this? Yeah, I think you get this, right? It's minus 0.02, and to get to the top, it's plus 0.02. I think we're going to encounter more scenarios yet, so and I'm going to base my review on that, whatever shows up next. Does this make sense? I know this is a little bit, this is not kind of something we relate to, but try your best. All right, let's keep going. State the precision and the uncertainty of the protractor. It all starts with precision, right? Before we get uncertainty, we need this. Precision is what? Smallest increment. And when there's a picture, you just look at it. And in this case, there, like this marking to that marking, there is a 10. We notice that this is, right, there's a 10 difference. There's 10. So you go from one marking to the other, and you notice that it's 10 degrees in this case because it's a protractor. So it would be 10 degrees. And the uncertainty, right, to get that, we just divide it in half. Whatever you get in the precision, divide it in half. And if you get the precision wrong here, and you divide it in half, you still get the 1 mark for uncertainty. So don't leave anything blank, because you'd be surprised what you can get here. Question. I'm going to draw a new one down here. I'm going to try my best. Let's just look at scenarios here because it's such a quick question. Let's draw our protractor like this. Try our best. This is 180. And then this is our center here. Let's say that that's 170. And let's say that's 160. You can still tell that my precision is 10, correct? But if whoever made this question had done this, what's the precision now? Precision is 5. Yes. Precision is 5 degrees. Your uncertainty would be 2.5 degrees. And that's because, right, you from one to the other, it's a 5 change, right? It's always 5. And so you have to read it carefully. It's what is it going up by from marking to marking, not from number to number. Like you have to be like from one mark to the other, right? What am I going up by here? And I did give you the high minus low divided by gaps. Do you remember that? If you want to use that one, it's probably a good one to use here. Okay, let's keep going. All right, keep going. 29. Here's another one of those. Tolerance is often used in construction, commercial, industrial. State an example where tolerance is used. Support your example with an explanation. So here you could say tolerance is important when it comes to like if you're given a vaccine. If the dosage is too low, it's not going to be effective. If the dosage is too high, it may cause an overdose, right? So there's tolerance. If you're installing a door, I don't know why I'm talking about this because they're no longer having this, but you never know, right? You never know what they're going to throw at you. So maybe if you just hear me say this, it might help you out. Next, Chris owns a candy factory that specializes in making chocolate candies. Explain why Chris needs to be very accurate when measuring his ingredients. What would you say here? It says, what does explain? Okay, so you have to give me a bit more than just a word or two. You can say so that the candy tastes, so that the candy tastes good. Wouldn't you say? Like if you're not accurate with your sugar, if it's not enough, if it's too low, it's not going to have a good sweet taste, which is what customers usually want. You can say to maintain the consistency. Yes. Shape, right? Sometimes if you don't put enough of an ingredient in there, the remaining product doesn't look good, right? It just looks like, what is this? Did they pick it up from the floor? What is this, right? I think one student once says to make sure that the price, right, what to charge for the candy, because if you, right, you kind of predict how much you're going to need based on what you put in. So that also gave that student a mark for that one. So again, don't leave it blank. Use your imagination. Yeah, is this English class or what? There we go. Next. Oh, that's the last one for precision. The maximum amount of stuffing that can fit in a pillow is 1,500 grams. The tolerance is 100 grams. State the nominal value, which is halfway between the minimum and the maximum. Okay, remember this. There's always max when it comes to tolerance, and there's always a min. We are given something here. They're giving us that the max is 1,500 grams. The min, we don't know what it is yet. But we do know the tolerance. What is the tolerance? 100 grams. Can we, there's at least two ways to figure this out, in my opinion. We are told that the nominal is halfway between the minimum and the maximum. So it's exactly in the middle here. That is what we call the nominal. This is exactly the same as the one before. I don't know why they made it. It's too similar, in my opinion. If this is 100 from the highest to the lowest, then we know that this is 50, and the difference here is 50. So to get from the max to the nominal, we would just subtract 50 from it. So it would be 1450. And subtracting it one more time would get you 1400, which is the minimum. Or you go max minus tolerance to get to the 14. But this is what they want. Or this is the average, right? You could go max plus min and divide that by 2. Right? 1500 plus 1400 divided by 2, 1450. So there's usually more than one way to get to what you need in that case. However, just so you know, in this case, they had to give you that it's halfway between, but the nominal could be anywhere. It could actually be the min. Remember the runway, for airplane, like the landing strip? It could be like, hey, it has to be at least this long. That's what we're aiming for. If you want to make it longer, it's not a big deal. It's actually probably a good thing. Okay, let's keep going. We're done with precision, then we're doing stats.